Question 1. In the context of a commercial walk-in freezer operating under high ambient conditions, the system shows a high suction pressure, low superheat, and frost on the suction line up to the compressor. What does this most likely indicate? A. Undersized suction line. B. Flooded evaporator. C. Restricted metering device. D. Overcharged system. Answer. Correct answer, B. Flooded evaporator. Explanation. These symptoms point to an evaporator receiving too much refrigerant, reducing superheat, and risking compressor damage. The frost indicates liquid refrigerant returning to the compressor. This may be due to a faulty TEV or improper bowl placement. ASHRAE Guideline 3 and EPA regulations emphasize preventing liquid return to avoid compressor failure and emissions. Question 2. Given the circumstances, a technician installs a defrost heater but connects it to the evaporator fan motor circuit. During operation, the defrost cycle triggers, but the fans continue running. What is the primary risk? A. Increased compressor run time. B. Reduced humidity control. C. Evaporator icing post-defrost. D. Moisture refreeze and coil damage. Answer. Correct answer, D. Moisture refreeze and coil damage. Explanation. Running fans during defrost can blow warm air into the refrigerated space and refreeze melt water on coils or surfaces, violating best practices under NEC Article 430 and manufacturer protocols. Defrost cycles must isolate fan motors to avoid ineffective melting and ensure safe operation. Question 3. Demonstrated by new EPA Section 608 regulations and Kigali Amendment compliance, which refrigerant management approach best aligns with environmental safety during a compressor changeout in a parallel rack system? A. Release a deduct refrigerant into the atmosphere. B. Vent refrigerant from the receiver only. C. Recover all refrigerant to an EPA certified cylinder. D. Transfer refrigerant to another system on site. Answer. Correct answer, C. Recover all refrigerant to an EPA certified cylinder. Explanation. EPA mandates full refrigerant recovery using certified equipment to prevent emissions, 40 CFR Part 82. Even though refrigerants must be managed responsibly. System-dependent or venting methods are illegal unless the system qualifies as exempt equals £5 charge. Question 4. When considering a reach and cooler running with air, the technician observes normal high side pressure but low evaporator pressure and high superheat. What does this most likely indicate? A. Oversized TEV. B. Blocked evaporator airflow. C. TSV is underfeeding. D. Non-condensables and the condenser. Answer. Correct answer, C. TXV is underfeeding. Explanation. Low evaporator pressure and high superheat typically indicate insufficient refrigerant flow into the evaporator. A malfunctioning TXV or incorrectly positioned sensing bulb are common causes. According to manufacturer installation instructions and system performance charts, superheat should be within target range to ensure efficiency and compressor protection. Question 5. In light of recent developments, a technician uses an ultrasonic detector near a condenser coil and hears intermittent clicking sounds. Bubble solution reveals nothing. What is the most accurate next step? A. Switch to UV dye detection. B. Assume noise is mechanical vibration. C. Pressurized system with dry nitrogen and retest. D. Replace the condenser coil. Answer. Correct answer, C. Pressurized system with dry nitrogen and retest. Explanation. Intermittent ultrasonic signals may indicate a small leak undetectable at low pressures. Bubble solution isn't always reliable under low pressure. Pressurizing to 150 sig with nitrogen per EPA Section 608 in RAG AGIP enhances leak detection reliability and prevents false negatives. Question 6. Based on the information, Mr. Delgado is tasked with installing a medium-temp vertical open display case in a grocery store. The case is placed directly under an air curtain and near the store entrance. 2 weeks later, the product temperature rises above the design limit. What is the most probable cause? A. System undercharged. B. Excess defrost cycle frequency. C. Air infiltration due to poor placement. D. Faulty defrost termination sensor. Answer. Correct answer, C. Air infiltration due to poor placement. Explanation: open cases must be protected from drafts and entrances. ASHRAE Refrigeration Handbook advises against locating open display cases near doors or air curtains, as infiltration disrupts the air curtain barrier, raising case temperature and compromising food safety and efficiency. Question 7. Throughout the course of service on a walk-in freezer, Clara notes that ice builds on the evaporator coil despite routine defrost cycles. She finds the defrost termination thermostat is stuck closed. What is the impact of this fault? A. Evaporator fans will remain off post-defrost. B. Coil will overheat, causing structural damage. C. Defrost will end prematurely, leaving residual ice. D. Defrost heater will run continuously. Answer. Correct answer: D. Defrost heater will run continuously. Explanation: a stuck-closed defrost termination thermostat prevents the system from ending defrost based on coil temperature per manufacturer guidelines and all 471. This results in extended heater operation, risking insulation damage and increasing energy consumption and service costs. Question 8. With the advent of variable speed compressors in multi-evaporator systems, what is a primary advantage of integrating floating head pressure control in commercial refrigeration? A. Reduces compressor cycle count. B. Enhances subcooling during peak loads. C. Stabilizes suction pressure. D. Increases seasonal energy efficiency. Answer. Correct answer: D. Increases seasonal energy efficiency. Explanation: floating head pressure control lowers condensing pressure based on ambient temperature, improving energy performance, especially in moderate climates. DOE and ASHRAE Standard 90.1 support floating head pressure strategies to meet energy efficiency goals in commercial applications. Question 9. Examining the consequences of poor return in a parallel rack system, what is the most likely symptom observed first? A. High discharge temperature. B. Compressor short cycling. C. Accumulated oil in evaporators. D. Liquid floodback. Answer. Correct answer: C. Accumulated oil in evaporators. Explanation: without proper oil management, oil can accumulate in evaporator coils, reducing heat exchange efficiency and starving compressors. Per ANSI ASHRAE Standard 15 and manufacturer best practices, proper piping design and oil separators are critical for long-term reliability and efficiency. Question 10. To illustrate this point, Mr. Hassan prepares to install a rooftop condensing unit for a restaurant's walk-in cooler. The site is level but surrounded by trees and adjacent to an exhaust fan. What is the most overlooked issue you must correct before proceeding? A. Lack of structural roof support. B. Inadequate line set length. C. Obstructed condenser airflow. D. Lack of electrical disconnect. Answer. Correct answer: C. Obstructed condenser airflow. Explanation: placement near trees or exhaust fans can block airflow or introduce hot discharge air, impairing condenser function. ASHRAE and manufacturer spacing guidelines specify clearance for air movement. Site layout must prioritize airflow to maintain efficiency and prevent high head pressure faults. Question 11. In a modern context of smart refrigeration systems, a technician observes that a control board intermittently loses power during startup. The voltage across the control transformer primary is stable, but the secondary voltage fluctuates between 24th and 17th. What is the most likely issue? A. Open neutral on the primary circuit. B. Fault control transformer. C. Undersized transformer for control load. D. Short in the compressor contactor coil. Answer. Correct answer: C. Undersized transformer for control load. Explanation: a fluctuating secondary voltage with a steady primary suggests an overloaded or undersized transformer. NEC 430.72 mandates control circuit power supply sizing based on connected loads. Smart boards, relays, and sensors increase VAR demand. Always verify transformer sizing against full control load. Question 12. Taking into account a system charged with R407 using the subcooling method, Mr. Jennings adds liquid refrigerant to the high side. He observes that the system pressure stabilizes, but subcooling remains below specification. What should he do next? A. Recover refrigerant and weigh it back in. B. Charge to target subcooling slowly in liquid form. C. Switch to charging by superheat method. D. Add refrigerant vapor through the suction line. Answer. Correct answer. B. Charge to target subcooling slowly in liquid form. Explanation. Our 407 Kis is a tropic blend with Glide, so it must be charged as a liquid into the high side to preserve its composition. According to ARI guideline and an EPA 608, charging by subcooling is accurate for systems with ESVS. Charging vapor can cause fractionation. Question 13. From the perspective of equipment lifecycle, a walk-in freezer installed in a loading dock area is exposed to frequent door openings. Temperature recovery is slow even though the refrigerant charge is verified. What design oversight most likely contributes to this issue? A. Low-efficiency insulation panels. B. TEV selected with excess capacity. C. Inadequate evaporator airflow. D. Oversized defrost heater. Answer. Correct answer. A. Low-efficiency insulation panels. Explanation. Frequent door openings expose the box to heat and moisture. If panel insulation is low R-value or improperly sealed, thermal losses are significant. Per dose standards, an ASHRAE 100 proper panel insulation equals R28 for freezers is critical to minimize thermal infiltration and maintain stable temperatures. Question 14. The primary reason for cycling compressors rapidly in a low-temp parallel system is often misattributed. If Mr. Griffin notices short cycling under low load conditions, what should be verified first? A. Suction pressure sensor accuracy. B. Compressor crankcase heaters. C. Discharge line vibration dampers. D. Oil separator size. Answer. Correct answer. A. Suction pressure sensor accuracy. Explanation. Short cycling is often due to sensor drift or improper control set points. Control logic relies on suction pressure or load demand. If pressure transducers send incorrect signals, the system may react prematurely. Always confirm sensor calibration as per OEM standards and NATE recommended diagnostics. Question 15. During the process of performing preventative maintenance on a flake ice machine, is Santos notices scale build up on the evaporator drum and slow ice production. What is the most likely root cause? A. Worn out gear motor. B. Improper flow switch adjustment. C. High mineral content in water supply. D. Oversized water pump. Answer. Correct answer. C. High mineral content in water supply. Explanation. Scale is caused by minerals precipitating out of hard water without a proper water filtration or softening system. Mineral buildup insulates the evaporator and reduces heat transfer. NS Fancy 12 guidelines recommend treating water to prevent scale formation and prolong equipment life. Question 16. By comparing two technicians' evacuation procedures, Technician A breaks the vacuum at 500 microns using refrigerant. Technician B pulls to 300 microns and holds. Who follows proper practice and why? A. Technician A, because introducing refrigerant proves system integrity. B. Technician B, because holding below 500 microns verifies no moisture or leaks. C. Technician A, because refrigerant absorbs moisture better. D. Technician B, because pulling to 300 microns ensures gas ballast is active. Answer. Correct answer. B. Technician B, because holding below 500 microns verifies no moisture or leaks. Explanation. Pulling and holding below 500 microns confirms no moisture or leaks per industry standards RE 740. Breaking the vacuum with refrigerant before verifying tightness is improper and could contaminate the system. Proper evacuation protects system reliability and meets EPA 600 requirements. Question 17. To what degree does an iced-up evaporator coil with warm product in a walk-in cooler indicate an airflow issue? Mr. Patel finds the coil frosted, fans running, but return air temp above set point. What is most likely the cause? A. TXB stuck closed. B. Failed fan capacitor. C. Dirty evaporator coil. D. Liquid line restriction. Answer. Correct answer. C. Dirty evaporator coil. Explanation. A dirty coil restricts airflow, causing cold refrigerant to remain too long in the coil, leading to ice buildup. Despite fans running, airflow is insufficient to prevent frosting. This is a common performance issue addressed in PM programs per ASHRAE 180 maintenance standard. Question 18. The underlying principle of evaluating superheat at the evaporator outlet is essential to system performance. If superheat is measured at 2 degrees from medium temp reaching case, what is the operational concern? A. Superheat is too high, leading to inefficient cooling. B. Subcooling is excessive and unbalanced. C. Risk of liquid refrigerant reaching the compressor. D. System is properly balanced and efficient. Answer. Correct answer. C. Risk of liquid refrigerant reaching the compressor. Explanation. Superheat below 5 degrees is too low and can indicate that the evaporator is flooded, sending liquid to the compressor. NATO OEM guidelines suggest 612 degrees superheat for TSB systems. Proper superheat prevents liquid slugging and protects compressor valves and internals. Question 19. When evaluating the merits of an installation, as to Barrow notices, a walk-in freezer has a drain line pitched at only 1/8 per foot. Water accumulates in the pan and freezes. What is the minimum slope per industry best practice? A. 1/8 per foot is correct. B. 1/4 per foot. C. 3/8 per foot. D. Horizontal is acceptable if heated. Answer. Correct answer. B. 1/4 per foot. Explanation. Drain lines should be pitched at a minimum of 1/4 per foot to ensure gravity flow and prevent ice formation per ASHRAE and IM guidelines. In low temp applications, drains should also be insulated and heated. Improper pitch causes water backup and ice blockages. Question 20. In summary of heat reclaim system applications, which of the following is the most efficient use of reclaimed heat from a condenser in a supermarket refrigeration system? A. Reheating defrost air. B. Supplementing air curtain operation. C. Preheating domestic hot water. D. Cooling the compressor room. Answer. Correct answer. C. Preheating domestic hot water. Explanation. Heat reclaim systems often direct waste heat to pre-IW, which offsets energy consumption for water heating. This aligns with ASHRAE Standard 90.1 recommendations for energy recovery in commercial facilities. It's more efficient than reheating defrost air or other auxiliary uses. Question 21. Under the assumption that a technician uses a micron gauge with a leaking hose to evacuate a commercial refrigeration system, what effect would this most likely have on the evacuation results? A. The gauge will show a false low vacuum, misleading the technician. B. The gauge will indicate a stable vacuum due to its internal compensations. C. The gauge will display fluctuating vacuum readings indicating a slow leak. D. The gauge will prevent evacuation beyond 500 microns automatically. Answer. Correct answer. C. The gauge will display fluctuating vacuum readings indicating a slow leak. Explanation. A leaking hose allows air intrusion, preventing a deep vacuum and causing fluctuations in vacuum readings. This can mislead technicians into thinking the system is properly evacuated. Proper leak-free connections per RE 740 and AS standards are crucial for reliable evacuation. Question 22. From the perspective of optimal refrigerant flow and oil return, what is the consequence of undersizing the suction line in a multi-evaporator commercial refrigeration system? A. Increased velocity leads to excessive noise but improves oil return. B. Reduced velocity causes oil trapping and compressor damage. C. Proper velocity maintained with minor pressure drop. D. No impact as long as insulation is adequate. Answer. Correct answer. B. Reduced velocity causes oil trapping and compressor damage. Explanation. Undersized suction lines reduce refrigerant velocity, causing oil to separate and accumulate in evaporators or lines, risking compressor failure, and ASHRAE guidelines specify minimum velocities, 3,000 feet minute, to maintain oil suspension and system reliability. Question 23. Considering the evidence a technician working on a commercial refrigeration system fails to use a lockout-to-gut LOTO procedure before servicing electrical components, what is the primary hazard this oversight introduces? A. Refrigerant leaks from accidental valve openings. B. Electrical shock or arc flash injury. C. Compressor mechanical damage during operation. D. Loss of refrigerant charge due to system venting. Answer. Correct answer. B. Electrical shock or arc flash injury. Explanation. LOTO ensures electrical circuits are denergized and cannot be accidentally energized, protecting workers from electrocution or arc flash hazards. OSHA 1910.147 mandates strict LOTO protocols for servicing industrial equipment to ensure workplace safety. Question 24. When analyzing a system with a thermostatic expansion valve, TSV installed with the sensing bulb on the suction line but showing erratic superheat, what is the most probable cause? A. Bulb is mounted too far from the evaporator outlet. B. Bulb is installed on a vertical section with liquid refrigerant. C. Bulb insulation is missing, causing false readings. D. TSV orifice is oversized. Answer. Correct answer. C. Bulb insulation is missing, causing false readings. Explanation. The bulb must be insulated from ambient air to accurately sense suction line temperature. Without insulation, the bulb reads ambient temperature, causing TSV to misregulate and superheat to fluctuate. Manufacturer installation manuals and ASHRAE guidelines emphasize proper bulb mounting and insulation. Question 25. Through the lens of energy efficiency, a refrigeration system with excessive liquid subcooling shows decreased cooling capacity. Which of the following explains this phenomenon? A. Higher subcooling improves capacity and reduces energy use. B. Excessive subcooling increases refrigerant volume in liquid line, reducing evaporator feed. C. Subcooling has no effect on capacity. D. Subcooling causes compressor overheating. Answer. Correct answer. B. Excessive subcooling increases refrigerant volume in liquid line, reducing evaporator feed. Explanation. Excess subcooling increases liquid refrigerant volume outside the evaporator, which can delay refrigerant arrival and reduce evaporator capacity temporarily. While subcooling generally enhances performance, too much can cause maldistribution. HVAC best practices suggest subcooling between 5 degrees. Question 26. During the process of diagnosing a walk-in cooler with frequent frost accumulation, a technician finds the hot gas defrost valve stuck open. What immediate impact does this have on system operation? A. Compressor overload due to reduced suction pressure. B. Continuous defrost leading to temperature rise in the refrigerated space. C. Rapid frosting due to defrost heater malfunction. D. Increased energy efficiency from continuous hot gas flow. Answer. Correct answer. B. Continuous defrost leading to temperature rise in the refrigerated space. Explanation. A stuck open hot gas valve allows continuous hot gas flow to the evaporator, raising the coil temperature and consequently increasing refrigerated space temperature, potentially spoiling products. Proper defrost control per a manufacturer specs is critical to prevent this. Question 27. Within the framework of EPA refrigerant leak regulations, if a system leaks 40% of its charge annually, what compliance action is required? A. Immediate system shutdown. B. Repair within 30 days and leak verification. C. Monthly leak checks until below 10%. D. No action required if under £50 charge. Answer. Correct answer. B. Repair within 30 days and leak verification. Explanation. EPA Section 608 requires leak repair within 30 days if annual leakage exceeds 35% for systems £50 charge. Verification after repair is mandatory. This reduces environmental damage and aligns with Clean Air Act provisions. Question 20. In an effort to diagnose a compressor that fails to start, a technician measures line voltage at the compressor terminals and finds it normal, but the compressor does not run. The next logical test is to A. Check compressor internal windings resistance. B. Replace the compressor immediately. C. Measure voltage at the contactor coil. D. Check the defrost thermostat. Answer. Correct answer. C. Measure voltage at the contactor coil. Explanation. Normal terminal voltage with no compressor start often means the contactor coil isn't energized. Verifying core voltage ensures proper control circuit function before replacing expensive components. This aligns with NATE troubleshooting best practices. Question 29. Across different scenarios, a technician notices uneven loading on compressors in a parallel rack system during low load conditions. What system adjustment improves load sharing? A. Installing fixed orifice metering devices. B. Adjusting suction pressure controllers to floating head pressure mode. C. Using capacity control devices like unloaders or variable speed drives. D. Increasing oil charge to compressors. Answer. Correct answer, C. Using capacity control devices like unloaders or variable speed drives. Explanation: capacity control devices modulate compressor output to match load, improving efficiency and reducing wear. ASHRAE and OEA guidelines recommend this for rack systems to prevent short cycling and maintain balanced compressor loading. Question 30. From multiple perspectives, a condensate drain line installed indoors shows continuous water accumulation despite correct pitch and insulation. What is the most probable cause? A. Improper trap installation or no trap installed. B. Drain line diameter too large. C. Excessive ambient humidity. D. Over-insulation causing condensation. Answer. Correct answer, A. Improper trap installation or no trap installed. Explanation: traps prevent air backflow and ensure proper drainage. Without a trap, air pressure can block drainage, causing water accumulation. Per IMC and ASHRAE guidelines, traps and venting are required to maintain system integrity and prevent ice buildup.